Bootstrap is a curricular module that teaches algebraic and geometric concepts by teaching students to program their own video games. Our mission is to leverage young students' enthusiasm for gaming and computing to reinforce and improve their performance and confidence in algebra. Bootstrap students never ask, when will we ever use this? Because we're already asking them to use algebra in concrete and meaningful ways. Each of our lessons is aligned to the Common Core Standards for Mathematics, which allows us to address a problem many teachers face: how and where to integrate programming and computer science instruction into the curriculum. Bootstrap uses a special algebraic programming language that behaves exactly the way math does. As an algebra teacher, you'll feel right at home, even if you've never programmed before. And while the programming itself is valuable, the ultimate goal is that students learn skills that they can use on a regular math problem. At the beginning of the class, Bootstrap students reverse engineer a simple video game to discover how coordinate planes and simple patterns are used to create animations. Once they've figured out how to make the game work, they are given the opportunity to brainstorm a game of their own. These games can be anything. For example, a leprechaun traveling through space, trying to collect coins while avoiding an angry robot. With the game in mind, we leverage students' engagement into the first steps of programming. Here we introduce the circles of evaluation, which serve as a visual spatial metaphor for function composition. These circles can easily be extended to other data types, defining algebraic rules over words, images, and animations. Students experiment with these expressions to create sophisticated collages, images, or a screenshot of the game they intend to build. From there, students are introduced to the steps required to define a function when given a word problem. Bootstrap emphasizes a structured approach to problem solving, in which students first read a word problem and generate the domain and range for the function. Based on the domain and range, students must then create two examples of how the function should behave, using sample data and describing what the results should be. Finally, students are asked to look at these examples and identify a pattern, generalizing to the formal function definition. Every mathematical concept we introduce is motivated by a concrete feature that students want in their game. Students make their game characters move by defining linear functions. When something flies off the edge of the screen, they detect it by applying Boolean logic and inequalities in the plane. When it comes time for them to make their leprechaun move up and down in response to key presses, Bootstrap introduces piecewise functions as a way to specify multiple behaviors over different values. Finally, when students want to detect a collision, the curriculum introduces the Pythagorean theorem, which students must derive and then apply to finish their video games. Each of these concepts is introduced as a word problem, and students get plenty of practice applying the recipe. Bootstrap leverages the concreteness and creativity of video game design to frame the importance of word problems, mathematical thinking, and the rigorous application of specific algebra skills. Students can use the design recipe to solve problems in their math book, working through the same series of steps they would use on a programming assignment. At the end of the module, students have a completed workbook filled with the word problems, notes, and math challenges from the class, as well as a video game of their own design, which they can share with their friends and family. More importantly, they have a set of skills they can apply to solve other problems, with or without a computer.